Hello and welcome to CSA 460 PLSI Design course. I'm Beg Rajibul Hassan and I will be your instructor for this lab session. This is the very first lab session of this course. In this session, we will be introduced to the concept of hardware programming. Specifically, we will learn about Verilog, which is a popular hardware description language or HDL in short. So this is how this presentation is organized. First, we will discuss about computer-aided design or CAD tools and the workflow of a typical CAD system. Next, we will detail the basic syntax conventions used by Verilog and how a digital circuit can be described in terms of them. We will continue our discussion by introducing the basic Verilog operations and the concept of subcircuits. Finally, we will wrap up this session with the introduction to some advanced Verilog data types. So before diving into the details of Verilog, it is crucial to have a working knowledge of general purpose CAD systems. So what are these CAD systems and why do we even care? But to answer that, we first need to acknowledge the fact that today's integrated circuits house millions of transistors on a single chip. As a designer, if you are to place all these transistors and interconnects and check the functionalities of the chip manually, it gets really frustrating in no time. So this is where the CAD systems come along. The CAD system provides the necessary tools to carry out the design and verification of the digital ICs. Tasks of a typical CAD system can be classified into four general categories, which are design entry, logic synthesis, simulation, and finally physical design. I will try to give you a brief overview of these tasks in the next couple of slides. So the first stage is the design entry stage. At this stage, the CAD system records the descriptions of the circuit provided by the designer in the form of the circuit schematic or a source code, which is basically the hardware description language or HDL that we're talking about. Next step in the design process is logic synthesis. This step, the circuit specifications are converted into a set of logic expressions, which are nothing but a collection of basic and or not operations. At the third step, these logic expressions are evaluated by the input values of the variables to check whether the circuit is functionally correct or not. And the final step, the CAD process, is physical design, where the logic operations get mapped onto the chip with the help of hardware resources of the CAD system. In this slide, we will summarize the complete design flow of the CAD system from design conception to chip configuration. So the first step is the design entry in the form of a schematic capture or source code. The second step is the logic synthesis, and the third step is the functional simulation. At this stage, if the circuit is functionally incorrect, the entire process will be repeated. Once the functionality of the circuit is verified, and system will move on to the physical design stage. Finally, the chip will be configured for further uses. For better understanding, let me walk you through this flowchart by using an example. Let's say we want to design a chip that has the functionality as discussed here. So at first, we need to enter these specifications into the CAD system, which can be done by preparing a schematic diagram of the circuit with the help of the graphical tools provided by the system at the design entry stage. Now the CAD system will move on to the logic synthesis step and convert the specifications into a set of equations like the ones we had at this design conception stage. Once the logic synthesis is done, the system will move on to the simulation stage where we can provide all possible values of the variables as inputs to the system and check whether the output matches our truth table here. If it doesn't match, the entire process will be repeated from scratch. Once the functionality of the circuit is verified, it's time to map these logic operations into the physical gates with the help of the gate library provided by the CAD system. Physical design is complete. It is ready to operate at the desired functionalities. So there are lots of CAD tools providers in the market. Among them, Potters2 by Altera and Vivado by Xilinx are two of the most commonly used CAD systems for the digital design process. We will be using Potters2 for performing the lab-related tasks in this course.